All right, today's lesson in our unit exponents is calculations with exponents. So we will be doing a bit of review of BEDMAS. So just to review that the E here in BEDMAS stands for exponents. All right, so the rules for order of operations or BEDMAS, they tell us what we must do for calculations. And then exponents comes immediately after removing brackets. All right, so brackets are still done first, and then we would do exponents. Just keep in mind, then division and multiplication comes next, but it's left to right. So if multiplication comes before division, you would do the multiplication first. And then you have addition and subtraction. And again, from left to right, if subtraction comes before addition, then you would do subtraction, all right? So division and multiplication are interchangeable, and then addition, subtraction are interchangeable, looking from left to right. All right, so let's take a look at a few examples. So our first example here, we have 5 cubed plus 5 squared. So what you can do with a question like this, it is addition. We can't apply any of our exponent laws. One confusion is that you can add the exponents, but you can only add exponents if it was multiplication. All right, so you cannot add the exponents here. All right, so with a question like this, we can calculate what 5 cubed is. So 5 to the power of 3 gives me 125. 5 squared, which is 5 times 5, that gives me 25. And my answer then would be 125 plus the 25, which is 150. All right, so just again, keep in mind, we cannot use the product law here because we are not multiplying the bases. All right, let's take a look at our next example. So here we have 5 plus 3 in brackets. So according to BEDMAS, we do have to do our brackets first. So any calculation inside the brackets first. So 5 plus 3 is 8. And then we still have the squared. So it becomes 8 squared, which is 8 times 8. And that would give me an answer of 64. All right, so our next example number 3 here, we do have a negative exponent. Does anybody remember what to do with an example like this? I'm just going to pause. Okay, so we do have the same base here. We have a base of 2 and a base of 2, and it is being multiplied, so we can use our product law. So we would have our base of 2, and our product law states we can add our exponents. So it becomes negative 1 plus 4. All right, so that would give me 2 to the power of 3. 2 to the power of 3, which is 2 times 2 times 2, which gives me an answer of 8. All right, so our example next, it is addition. All right, so we cannot use the product law here. We do have a negative exponent and a negative exponent here. So the first one, recall that if we have a negative exponent, our base, we have to take the reciprocal of the base. Yes. So this would become 1 over 3 to the power of 1 plus 1 over 3 to the power of 2. All right, so the 1 over 3 to the power of 1, that's just 1 over 3. And then this part here, it's squared. So 1 times 1 is 1. And then the 3 squared becomes 3 times 3, which is 9. All right, and now we have addition of fractions. So we would here have to get the same denominator, common denominator. So we would multiply by 3, top and bottom. So I'm just going to show that here, that I'm just going to multiply by 3, and I'm just going to multiply by 3. All right, and that becomes 3 over 9 plus 1 over 9, which gives me 4 over 9. All right, so for the first one, we have 5 cubed being multiplied by 2 cubed. So we cannot apply any of the exponent laws because our bases are different. So 5 cubed, you would just put that in your calculator, 5 to the power of 3. That will give you 125. All right, and then 2 cubed, 2 times 2 times 2, which is 8. All right, and then that dot in between there means multiplication. So we're multiplying 125 times 8, and that should give you 1,000. All right, for this second question, so BEDMAS, so we would do brackets first. All right, so 3 to the power of 0, that's 1. And then 5 to the power of 0, that's 1. And it's brackets next to brackets, so that does mean multiplication. And then it's all to the power of 6. 1 times 1 is 1, so it's just 1 to the power of 6. And 1 to the power of 6 is just 1 times 1 times 1 times 1, 6 times. So the answer would just be 1. All right, so the last question here, we have 5 to the power of 10 divided by 5 to the power of 7. So our bases are the same. So we can apply our quotient law, which would be 5 to the power of 10 minus 7, which gives me 5 to the power of 3, which is 5 times 5 times 5, which gives me an answer of 125. All right, for these next type of questions, we have to do substitution first before we can proceed with BEDMAS. So here we're told A is equal to 3, B is equal to 2, and C is equal to -1. So we would substitute those values in first and then proceed with order of operations. So first one, A is 3 plus B, or B is 2, and it's all to the power of C, or C is -1. All right, now we would go ahead and proceed with order of operations. So we would start with our brackets, 3 plus 2, which is 5. So 5, and then it's to the power of -1. So we would just take the reciprocal of that, which becomes 1 over 5 to the power of 1, which is just 1 over 5. All right, so I'll pause here and let you guys try that next one. All right, so for our second one, I've already completed the substitution. So what you can do here is you can apply the power of a power law right away. So that becomes 3 to the power of 2 times -1, which is -2. All right, that's going to make us take the reciprocal of the base, which becomes 1 over 3 to the power of 2, which becomes 1 over 9. You may have done it where you did the bracket first. So 3 squared, which is 9. And then you still have to the power of -1. And we just had to take the reciprocal of that, which becomes 1 over 9. To the power of 1, which is still 1 over 9. So either way, you would have gotten the same answer. All right, I think most of you already completed the third one. So let's go ahead and substitute for this. A is 3 over B, which is 2, and it's all to the power of -1. So all we have to do here is take the reciprocal of our base. So it becomes 2 over 3 to the power of 1, which is just 2 over 3.